All right, let's talk about the biggest story ever told. No, not about a person, not about a nation, but the story of literally everything. We're going to dive deep into the science of the universe, from just how unbelievably big it is to where it all came from. So, you ready? Let's take a trip through space and time. Okay, first up, an unimaginably big universe. And I mean, we really have to try and wrap our heads around the sheer scale of it all. It's it's almost impossible to really feel how big it is, but we're going to give it a shot. Which brings us to a pretty fundamental question. Seriously, how big is the universe really? Like, does it just stop somewhere? Is there a wall at the end? Or does it go on forever? The truth is, nobody knows for sure if it's infinite. But what we can talk about is the part we can see, the observable universe. And let me tell you, the numbers we're dealing with here, they're just mind-blowing. Okay, get ready for this. 100 billion. Just let that number sit there for a second. That isn't the number of stars, it's not planets. That's the estimated number of galaxies in the part of the universe we can see. Entire collections of stars. And believe it or not, that's just the beginning. Yeah, because inside every single one of those 100 billion galaxies, there are billions more stars. We're talking billions of suns, kind of like ours, all packed together. The grand total number of stars, it's a number so big it's practically meaningless to even try and say it. And here's the wild part. All of that stuff, it's all contained in a vast, mostly empty space. You have to remember, the universe is defined just as much by the incredible nothingness between things as it is by the things themselves. It's like a few grains of sand scattered across an entire desert. That huge, dark emptiness is the stage for everything. So, you can probably guess that kilometers or miles aren't going to cut it when we talk about these distances, right? We need a whole new cosmic measuring tape. So let's start close to home. We've got the astronomical unit, or AU for short. That's basically the average distance from the Earth to the Sun, about 150 million kilometers. Sounds like a lot, but out here, it's like walking to your mailbox. Okay, to get to the next star, we need a much bigger step. That's where the light year comes in. And let's clear this up right now. A light year is a measure of distance, not time. It's how far light, the fastest thing there is, zips through space in a single year. And that distance is, well, it's about 9.46 trillion kilometers. Absolutely enormous. But what about the distances between galaxies? We've got to go even bigger. For that, astronomers use something called a parsec. Now, the science behind it is pretty cool. It's all about how stars seem to shift against the background. But what you really need to know is this. 1 parsec is about 3.26 light years. This is the big one. This is how we measure the truly epic voids of space. All right, so the universe is ridiculously, mind-bogglingly big. Got it? But that just leads to an even deeper question. Where did it all come from? What's the ultimate origin story? Well, for a while, there were two big ideas duking it out. On one side, you had the steady state theory. This idea was pretty simple. The universe has just always been here. No beginning, no end, it just is. But on the other side, you had the Big Bang Theory, which said, nope, the universe absolutely had a beginning, and it's been expanding ever since. And as scientists gathered more and more data, the evidence started piling up on one side. Today, the consensus is clear. The clues all point to an expanding universe, one that exploded into being from a single, hot, dense point. So let's go back in time and check out that incredible beginning. So let's talk about the first 3 minutes. A brief history of the beginning of time. And when I say brief, I mean things happened faster than you can possibly imagine. It's a wild ride. So picture this. At point zero, everything, all the matter and energy in the entire universe is crammed into a single point of unimaginable density and heat. We call it the singularity. Then, bang! In a tiny fraction of a second, this tiny ball undergoes a huge expansion. Pure energy starts turning into the very first bits of matter. In just the first 3 minutes, the first atoms, the building blocks of you, me, and everything, are forged. It's still a hot, soupy mess, though. It actually takes about 300,000 years for things to cool down enough for the universe to become transparent, finally letting light travel freely through space. Okay, that is one heck of an origin story, but it sounds like science fiction, right? So how can we be so sure? Well, it's because an event that big doesn't just happen without leaving a trace. We're going to follow the cosmic clues, like detectives piecing together the evidence the Big Bang left behind.
the biggest clue of all is that expansion is still happening. And you've got to understand this because it's weird. The galaxies aren't just flying apart through space, like shrapnel from an explosion. No, it's weirder than that. The fabric of space itself is stretching. Think of it like dots on a balloon. As you blow up the balloon, the dots all move away from each other because the balloon itself is expanding. That's our universe.
So, what are the fingerprints of this massive event? If this story is true, what kind of evidence should we be able to find out there today?
Okay, so there are three huge smoking guns. First, when we look at light from other galaxies, it's redshifted. Think of it like the sound of a siren changing as an ambulance moves away from you. This redshift in light tells us those galaxies are moving away from us. Second, and this is the really cool part, the further away a galaxy is, the more its light is redshifted, meaning it's moving away faster. That's the perfect signature of an entire universe expanding from one starting point. And the third piece of evidence? There's this faint energy, this afterglow, all over the sky. It's called the cosmic microwave background radiation, and it's literally the leftover heat from that initial cosmic fireball.
So we've gone from the very beginning of time to the evidence for it all. Now let's find our own galactic address. Let's zoom way, way in to find our own place in the cosmos. Because all those stars aren't just floating around randomly. They're gathered together in these incredible structures we call galaxies. And these giant star cities basically come in three main flavors. You've got your spiral galaxies, which have these beautiful swirling arms. Then you have elliptical galaxies. They're more like huge glowing blobs of stars. And of course, you've got the irregular ones, which are exactly what they sound like. They don't really have a set shape at all. And our home? Our little spot in the universe? Well, it's a spiral galaxy, and we call it the Milky Way. We're not even in the center. We're kind of out in the suburbs, on one of those spiral arms. It really puts things in perspective, doesn't it? Our whole world, our sun, everything we've ever known is just a tiny, tiny speck in this one galaxy among billions of others. So there you have it. The universe began 13.7 billion years ago, and it's still expanding today. We've seen just how big it is, how it started, and where we fit in. But it leaves you with this one last, absolutely mind-bending question to think about. Where is it all going? If the universe is constant question to think about, where is it all going? If the universe is constant...